Find the first 12 derivatives for the function f of x equals sine x, then determine the 100th derivative f100 of x. So f of x here is the sine of x, which means that the first derivative f prime of x is the cosine of x, which means the second derivative of x, the derivative of the first derivative, will be a negative sine x, which means that the third derivative, the derivative of the second derivative, will be a negative comes along the derivative of sine is a cosine, which means that the fourth derivative of x, once we go to the fourth and higher, we use a 4 in parentheses instead of writing a whole bunch of primes, but it will be the negative of the derivative of cosine, negative sine x, which means it goes back to being a sine x, just like the original function. Which means that the fifth derivative will be just like the first derivative, it will be a cosine. The sixth derivative will be just like the second derivative, it will be a negative sine. The seventh derivative will just be like the third derivative, and it will be a negative cosine. The eighth derivative will be like the fourth derivative, and that's like the original function, sine of x. The ninth derivative will be just like the first and the fifth derivative, cosine x. The 10th derivative will be just like the second and sixth derivative, negative sine x, and then the 11th derivative will be just like the third and seventh derivatives, and that'll be a negative cosine x. And by the 12th derivative, we will be once again starting the pattern over, and it goes back to the sine of x. The point of this is the derivative is repeating itself every 4 derivatives for the sine of x. And that's why I'm stacking the way I am, so that you can see across that every 4th derivative matches. From there, we can determine any high-order derivative for this function. For example, f100 of x. Well, 100 is divisible by 4. So the 100 is equivalent to the 96, the 92, the 88, the 84, on and on down. And it's equivalent to the 12th derivative, the 8th derivative, the 4th derivative, and the original function, since it's divisible by 4. If it's divisible by 4, it will be like the original. If it's divisible by 4 with a remainder of 1, it'll be like the first derivative, remainder of 2, like the second derivative, remainder of 3, like the third derivative. In our case, it's divisible by 4. It's like the original function, and it's just going to equal to sine of x. And therefore, we don't have to go through 100 derivatives. We can speculate what it will be, and it'll just be a sine of x.